Hola, mi clase. Alrighty, lessons 1 through 4 of Unit 4. First note taker for the unit. So we are working on solving linear equations, so equations that make straight lines, with variables on both sides of our equal sign. So we've seen that recently, and that's where we have our both sides of our hanger, both sides of our balance, and then we've been writing equations where we saw that we have x's on both sides. So we have a lot of vocabulary, so you're going to definitely need to push pause, lift your flap up, and start copying these down. Once you're done copying, then push play. Remember, lift your flap up and write the words and stuff underneath. So equivalent equations, this is one of our newest vocabulary. It's where equations that have exactly the same solution. These are the ones we've been writing where it says, x plus 4 equals 6x plus 5, right? They're equivalent. And then we've been simplifying things and saying that these are the same because we can do the same thing to both sides. And we'll get into this a little bit more when we finish lesson 4 tomorrow. An expression is review from last year. So this is a set of numbers, symbols, or operators such as adding and multiplying. That's a multiplying symbol. Grouped together to represent a value. They're not like equations. So unlike equation, expressions do not have equal signs. So we still have x's, we still have adding and subtracting, multiplying and dividing, but they don't equal anything. And all we can do is simplify them to the smallest amount we can. So we've talked about solutions last unit. We're going to continue talking about them now. So it's the value or set of values that make equations true. So they would keep the left equal to the right. That's when we found, the rectangle equals 0. In your homework, you had an answer that, the triangle equaled 9 or whatever it was. I can't remember the exact answer, but that's the solution that makes it equal, makes it true. Now later in this unit, we're gonna have solutions where we have 2 variables, so x and y, and it's where the pair together make the value of the equation true. So it's often written as an ordered pair x and y. Right now, for lessons 1 through 4, it's just 1 variable, but when we get into the rest of the unit, it's going to have 2 variables. Distributive property is review from last year. The distributive property says that we multiply a number by the sum of the 2 or more terms and equal to multiply the number of each term separately before adding them together. Now, this is sum. We can do subtraction or difference as well. So it's not always just sum. It can also be subtraction or difference. And then like terms is also review from last year. So 2 or more terms that have the same variables, exponents, numbers, decimals, and fractions are all like terms. So these are our constants, these numbers, fractions, these are constants. And then we have our variables. So those are when we can cross off x's in circles, right, those are our variables. But when it says numbers, decimals, and fractions are all like terms, that's when there are constants. All right, so let's start getting into answering some of these questions. So it says, which of these moves would keep the hanger in balance? Select all that apply. This is a really important question. Maybe start. This is for our unit, very clearly for our unit. So add 2 circles to the left side. So if I do that, and then add 1 square to the right side, that keeps that balance because I have 2 squares there and I have a rectangle there. They are the same and even. So yes, that would work. Okay. So this is me kind of checking why they work. All right. The next one says add 2 triangles to each side. So if I add a triangle here, 2 of them there, and 2 of them there, that definitely keeps it balanced. I did exactly the same thing to both sides. So when I do exactly the same thing to both sides, it keeps it balanced. So that one's true. All right. The next one says add 1 triangle to the left. Okay. And then add 1 square to the right. Well, the squares definitely cancel. The triangles cancel. But here's the problem. That's not balanced. Nowhere does it say that those are equal. So that will not work. Okay, that's a no. Okay, we can even go like this. Oops, that's not what I meant to do. No. All right, remove 2 circles from the right side. Remove and 1 square from the left side. All right, that is balanced because it's a triangle equal to a triangle. So yes, that is balanced. Okay, and then the last one says add a circle to the left. Oh, gotta get my drawing tool. Add a circle to the left and a square to the right. Okay, circle to the left, square to the right. So I can remove my squares, I can remove my triangles, I can remove my circles. Oh, that's not balanced. To be balanced, it needs to say circle equals circle. So that does not work. All right, so that's the strategy I would use to answer this type of question. Definitely make a note that this is a test question, so highlight that question. All right, we have problems 2 through 4. Mine separated, so that's why I scrolled the way I did. Yours should be all together. So it says determine whether each point lies on the graph of the linear equation 4x minus y equals 3. Write yes or no. This is review from our last unit, but plugging in numbers into equation is going to be really important for this unit as well. So I definitely want to go over this because it'll come up later when we talk about, like if you look down at question 5 or on the next page for you, I don't know, it says to check your solution. So this is very similar. So we have 0, 3. So this is x, this is y. If I look at my equation, it says 4 times 0, that's x, I inputted it, minus 3, that's y, I inputted it. We want to know if that equals 3, right? This is kind of our question mark. Well, 4 times 0 is 0, minus 3, we want to know if it equals 3, question mark. Well, if I have nothing and I take away 3, I get negative 3. Well, that does not equal 3. So the answer is no. That's how you see and determine if it does lie on the graph, because if it's true, it then, of course, lies on the graph. All right, number 3, we're going to use 3/4. Again, this is x, this is y. Same exact equation. I'm going to go 4 over 1, and that's because I need to input a fraction, so I want to multiply by a fraction. And then I'm going to subtract 0. I'm not so worried about that being a fraction because it is 0. And I want to know, question mark, is that 3? Well, if I multiply straight across, because that's how we multiply fractions, I get 12 over 4 minus 0. Does that equal 3? 12 divided by 4 is 3 minus 0, 3, question mark. 3 take away nothing is in fact 3. So since that is true, we write yes. Got to do math in math class. So next one, this is x, this is y, same exact equation. 4 input negative 1 minus input negative 7. Now remember that minus sign does not take care of that negative sign. They both have to be there. I want to know if this equals 3. Well, 4 times 1 is 4, and a positive times a negative is a negative. And then I have minus a negative. We would add the opposite, and now it's plus 7. Does that equal 3? We need to remember from last year, we subtract when they're opposite signs. So 7 take away 4 is 3. And because 7 has a greater absolute value, the answer is positive 3. And that does, in fact, equal 3. So we can say yes. All righty, let's keep moving. Question 5 is also from this unit. This is a unit 4, lesson 4. We're going to get into this tomorrow, but I want to go over it. So we're going to actually use algebra and math to solve these equations because what we saw at the beginning of lesson 4 is using our pictures isn't helpful when I have 12 x's. So we also saw that we can solve these in a couple of different ways. So I could first choose to divide by 3 because this is divisible by 3. That's divisible by 3. I get x minus 4 equals 4x. I can do that. Okay, now I could move, I'm going to move my x's so they're together. So this is a positive x, so the inverse is a minus x. So I'm going to minus x from both sides. Remember, everything I do to one side, I have to do to the other side. Now I'm going to get negative 4, because that's negative 4 right there. And then 4 x's take away an x gets me equal 3x. And then I'm going to divide by 3, because I need to get that x by itself. And I can leave it like that. Negative 4 over 3 equals x. Okay, so that's one way you could do the equation. I'm going to actually show you another way. So I'm going to go like this, and I'll show you another way. So the second way I'm going to do it is I'm actually going to take my equation, 3 parentheses x minus 4 equals 12x. And I'm actually going to distribute first. So I get 3x minus 4 equals 12x. Now it should come out the same answer. So as long as I did my math right, it should come out the same answer. Oh, I made a mistake. Hold on. I did not distribute here. See, you got to check your work. 3 times negative 4 is negative 12. I apologize. There we go. So I'm going to now get my x's again together. So positive 3x inverse is negative 3x. And we're going to get negative 12 equals 9x. I'm going to divide by 9. Now, you're probably thinking, that does not equal the same. But look, I can reduce these both by 3. And I get negative 4 thirds equals x. So I did get the same answer. I did it 2 different ways, and I got the same answer. Now, that's just solving. The second part of this question says you need to check your solution. So what I would suggest is maybe lifting up your flap. If you don't have room. I clearly don't have room. I have a lot of big handwriting. If you do not have room, you need to lift your flap up as well. I'm going to check my solution. So for space-wise, I can actually do it down here because I know the next problem. I don't need that space. So what we do to check our solution, right? So this is to check the solution. What we do is we take our answer, we set x as negative 4 over 3, and we actually go back and plug it in or input it into x and see if this is true. So we go 3 parentheses, negative 4 over 3 minus 4 equals 12 times negative 4 over 3. I'm just inputting it. Okay. Now I'm going to multiply first. I'm going to distribute. I don't want to have to subtract with fractions, so I'm going to do this first. So 3 times, I can put this over 1. 3 times negative 4 is negative 12. 1 times 3, right here, is 3. And then I go minus 12 equals, again, put this over 1, multiply straight across. That's negative 48 over 3. Okay. Now, again, you're probably like, well, I don't want to do that. Well, you don't have to. Watch. Negative 12 divided by 3 is negative 4. You get nicely cleaned up. Okay. We could divide this, right? I could actually reduce this or divide this over here. So I'm going to go 3 into 48. Okay. 3 goes into this once. And 3 goes into 18 6 times. And it's a negative divided by a positive, so it's negative 16. And then if you look, I have negative 4 minus 12, so I'm going to add the opposite. Now I have both negatives, and 4 and 12 also make 16. And because they're both negative, it's still negative. And look at that. The answer does work. So that's what it means by check your solution. Okay? Again, we're going to talk about all of this when we finish lesson 4, but it's a good starting point so you can kind of get some ideas for finishing it. All right, number 1 in test practice. This is a review question from our last unit, which we will have retakes for. So it's really important we figure out why and how. So the first thing I would do is I would go look at the y-intercept, right? This number here, these are our y-intercepts. So that's the first thing I would go look at. Remember, the y-intercept is where it crosses the y-axis. So if I look at my red line, it crosses the y-axis right here. If I count, that's 1, 2, 3, 4, 5, and 6. So the y-intercept is at 0, 6. Well, the only ones that say plus 6 are B and A and B. So I'm going to get rid of C and D. They don't even help me. Now the next part is look at my slope. So my slopes are both negative. Well, that line is negative. It goes down from left to right. So what I have to do is find my slope. So we need to find some points that are easy to find. I'm going to use my y-intercept, and then I'm going to use my x-intercept because it's easy to find. So I go 1, 2, 3, 4, 5, 6. But I went down, so it's negative 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. I went to the right, so it's positive 9. If I go negative 6 over 9 and reduce it by 3, I get negative 2 over 3. And that's why it's A. That's how I would go through that problem. All right, 2 more. All right, I'm gonna go over this problem in 2 ways. So it says problems 2 and 3, determine whether x equals negative 3 is a solution for each equation. Show or explain your thinking. I'm gonna show you 2 ways you can do this. Okay, so way number 1 is just to solve them. Okay, so I'm gonna just solve this. So I'm going to distribute. I get negative 2x minus 4, because a negative times a positive is a negative, equals negative 10. Now, the negative 4 and the 10 are constants, so those are like terms that I want to get together. This is negative 4, so the inverse is positive 4. Do it to both sides. We get negative 2x equals negative 6, because they're opposite signs, we subtract, and then keep the sign of the greater absolute value. We divide by negative 2, because that's multiplication. The inverse is division. Take the negative with you. A negative divided by a negative is a positive, and 6 divided by 2 is 3. They want negative 3. So right now, it says that this would be no. Okay, so I'm going to show you one other way to do this, and that's to just input negative 3 and see if it comes out true. So it looks like this. Negative 2, just use your equation. Input negative 3 plus 2 equals negative 10. So, right, I inputted it as x. Negative 2. Negative 3 plus 2 is negative 1. Right, because I have more negatives than positives. Equals 10. A negative times a positive is, a negative times a negative is a positive, and 2 times 1 is 2, equals 10. And that's a no. So see, I proved it in 2 ways why it is not a solution. All right, last problem. So let's do it both ways again. We're going to solve. So I'm going to distribute. Distribute is where we multiply. 8 times x is 8x. 8 times negative 1 is negative 8, equals 18x plus 22. So we're going to get our like terms together. Let's do our constants first. So I'm going to add 8 because I don't like negatives. So I'm going to get rid of that first. 8x equals 18x plus, what is that, 30? That's nice. Now, I do want to move my x's together, so I'm actually going to go this way. If I move my constants one way, I want to move my variables the other way. Now, 8x's take away 18x's will get me a negative, because I am taking away more than I have. And then I'm going to have 10x's, because that's how many I have left, right? I subtract and keep the sign, and that's going to equal 30. So I divide by negative 10, because this is multiplication. The inverse is division. And a positive divided by a negative is a negative. 30 divided by 10 is 3. And look at that, we got negative 3. Now, if we do it the other way, this is kind of like checking our solution like we did on question 5. So I'm going to go 8 parentheses negative 3 minus 1 equals 18 times negative 3. I'm just inputting x plus 22. So 8 parentheses negative 4 is negative 3 minus, add the opposite. You can now see they're both negative, equals, well, 3 times 8 is 24. 3 times 1 is 3 plus 2 is 5. And then it's negative because it's not positive and a negative. And then plus 22. And then I go, okay, 8 times 4 is 32. But it's a positive times a negative, so it's negative. And then this is opposite side, so I subtract. So 4 take away 2 is 2. 5 take away 2 is 3. I have more negatives, right? Negative 54 has more than 22, so it's negative. And look at that, they were the same. So check, it is a solution. So this one is yes. So we can do it two ways. We can solve it and see what the solution is, or we can just check our solution and see if it's true. All right, until next time, adios.